Good morning. We are continuing with chapter 6, which is text fields and loops. So just as a very brief recap, we covered text fields last time. In general, they're pretty easy to use. The big caveat is they're not in the widget library. They're not technically widgets. They are native components. And as a result, they're not going to respond and react exactly the same way the rest of the widgets will. We haven't really run into a situation where that's an issue, but we will. So I remind you so that when we get to an oddity with the text field, you remember, oh yeah, that's right, text fields. The second half of the chapter is on repetition, which is usually paired up with or covered right after Boolean logic and then if-then statements. So we've covered Boolean logic, we've covered if-then statements, basic logic, writing if-then statements, getting stuff to happen if something is true or something else to happen if something's false. And you guys have had a lot of practice doing that. So the next step is, how do we use logic to make something happen more than once, to make something happen repeatedly? That is typically called repetition, or more colloquially, just looping. There's three classic cases of repetition, and I have them numbered 1, 2, and 3. So one is you need to repeat some action, which is just some bit of code, some chunk of code. It could be a single line of code. It could be a huge chunk of code. But you need to, situation 1 or case 1 is you need to repeat it a certain known number of times. You know you need to do something, for example, 4 times. Case number 2 is you need to repeat some chunk of code 0 or more times, but you don't know how many times. You can figure out how many times, you can figure out how to programmatically decide that you're done repeating, but in advance of doing it, you don't know whether it's 4 or 8 or 200. You'll know it when it's done. That's case number 2. Case number 3 is really similar to case number 2, and that is you need to repeat some chunk of code 1 or more times. You don't know how many in advance. You are able to tell when you're done. The key difference between 2 and 3 is case 3, you know you need to do it 1 time. It is guaranteed that you'll need to perform some task once, and then maybe again and again, but maybe not. So in case number 3, your chunk will run 1 time. In case number 2, it may not run at all. Those are the 3 classic cases. This is a table from the book with a kind of a running example that's I hope is easy to understand or to illustrate these ideas with something more than just a definition. So the running example is you're in a group, there's 4 people, and you're going to be having a meeting, and you guys do some stuff at your meetings. You always remind everybody in advance of the meeting. Sometimes you bring pizza, and you always bring root beer. So there's a need for someone to call everyone and remind them of the meeting. There's a need for someone also to call everyone if pizza's needed and get someone to volunteer to bring the pizza this week. And there's a need to contact everyone in the team again and get someone to volunteer to bring the root beer. So these are the 3 classic tasks. So how is that? Because that may not seem like it matches up perfectly. So case number 1 is you need to repeat a task a certain known number of times. So the example is you're going to contact each member on your 4-member list on your team to remind each one about the upcoming meeting. The loop recommended for that case is the for loop. So how do we know it's a case number 1? It's a case number 1 because I know this number. If I know I need to do something 4 times, or I just know the number, then I'm in case number 1. And the recommended loop for case number 1 is the for loop. Okay, case number 2, if pizza is needed at the next meeting, you're going to contact members on your list until someone volunteers to bring it. So this is the 0 or more times task. It's 0 because you don't always bring pizza. Maybe you bring it every other week. Maybe you bring it if the meeting's on a Tuesday and that there's a coupon for pizza. I don't know what the rule is necessarily, but your team does like to get pizza, but they don't get it every meeting. So it's a 0 or more situation, because it could be you're not going to contact anyone to bring the pizza. But if you do need to contact people to bring the pizza, you're going to call everyone in your list. The problem is people say no. So you might call one person and they say no. You might call the second person and they say yes. So then the loop would end after 2 repetitions, but you don't know in advance who's going to say yes. And in fact, you might call all 4 people on the list and they all may say no. And then you may need to start over and do a second round of calls and say, hey, I've gone through the list. I'm calling you for a second time because we still don't have a volunteer for pizza. Please don't be so cheap. Say yes. But the idea of situation number 2 is you just don't know. It could be you don't have to call anybody. It could be the first person you call. Just no telling. So that's case number 2, and the recommended loop for case number 2 is called the while loop. Okay, case number 3. Case number 3 is a little bit simpler in some ways in that it's every meeting somebody brings root beer. It's your job just to call and see who's going to bring it this week. So you'll start off with the first call. If they say yes, then you're done. If they say no, then you move on to the next call, and the next call, and the next call, until you get somebody who agrees to bring the root beer. This is a 1 or more time loop because you bring root beer every week. So you have to at least make 1 phone call to see if the first person up will agree to bring the root beer. The recommended loop for this is the repeat until loop. So there's 3 loops in Lua: the for loop, the while loop, and the repeat until loop. And they're geared toward slightly different variations of this basic repetition task. It is obviously recommended that, if at all possible, you choose the loop that meets your needs the most closely. That is, as you start thinking about what it is you need to repeat, you think to yourself, well, do I know how many times I need to loop? If I know how many times I need to loop, then the for loop is probably the best fit. If I don't know in advance how many times I need to loop, then the for loop is a less good fit. And maybe a while loop or a repeat until loop are the better choice. And obviously the choice between those 2 is, do I know I need to do something once and maybe more times? If so, that's case 3. Or is it possible that I don't need to do it at all? Depending on how the logic plays out, I may not need to execute the code even once, in which case that's a 0 or more times case, and that's the while loop recommended. All right, so my plan today is essentially to dive into the for loop and give you some examples, some follow-along stuff, to get your head into repetition. So one more, not really an analogy, but a way to think about loops or repetition. You could think of any of these as something like a repeated if statement. We learned if statements over the last week, and the if statement just tests some Boolean condition, and if it's true, the if statement then runs some code. There are more complex permutations of that. There's else's and else ifs and other stuff that you've worked with, but the very basic if statement is just an if, then a condition, and then some code that's executed. So loops are, in lots of ways, something like a repeated if statement. If you tell your computer to check this Boolean condition and then to keep checking it over and over, and as long as it's true, to perform some task, that would be like a repetition. It would be a repetition. All right, so to give us something concrete to loop through, I've got a little table here called teammates, and I've got 4 teammates: Harry, Ginny, Ronald, and Hermione. These are obviously completely random names. They should not be inferred to be part of any sort of ongoing movie franchise or copyrighted or trademark works of any sort. Harry, Ginny, Ronald, Hermione. So there is an upcoming meeting. You guys are getting together, and unluckily, you're the team secretary. You're the one in charge of contacting everyone, at least this week, to make stuff happen. So just conceptually, let's start with the for loop. Let's look at the syntax and what it might look like to do something like this. I am pretending that there's a method, I'm pretending that there's a function in Lua called placeCall, maybe that you've written, that will dial the phone for you, according to some script. There is no such function, nor am I going to be writing a function like this to make it happen. It's a pretend function to work on this illustration of you're having to call people. Okay, why is it a for loop? This is a for loop because your job is to call everyone. If they answer the phone, you'll remind them. If they don't answer the phone, you'll leave a voicemail. Either way, you start with the first person in the list and you work your way down to the last person in the list, and then you're done. The easiest possible scenario. So what does a for loop look like syntactically? There's a few key requirements. There's the keyword for. There are 3 bits of information here separated by commas. There's the keyword do, and then there's the keyword end. So between the keyword do and the keyword end is the body of the loop. Any statements in here are part of that chunk of code that will be repeated as many times as the loop executes. So I've just got a comment in here to start. The 3 bits of information. The for loop works with an integer counter that you get to name. So I've called it n here. So I say for n equals start, that's the number you want to start at. End is the number you want to end at. And step is the counting rule. That is for each loop, how many numbers, how many integers do you want to jump up or increment up to do the next loop. 1 is the default. And so if it is a 1, you can leave that off. I don't do it here, but I will do it in actual coding, just because typing those 2 extra characters is tough, and I like to economize my fingers, Anyway, so 3 pieces of information: the starting number, the ending number, and the step or increment rule. So here's the specific example for our team. We have this team data. It's a list of teammates. It's in a table called teammates. We set it up on the prior slide, right here. So how do we write out the for loop? So the first question is, well, what's the start? What number do I want to start at? If I'm looping through a Lua table, you need to remember that the first item in the table, the first member in the table, is at index number 1. That's different than most other languages that start at 0. Lua starts at 1. So if you're looping through a table like this and you want to start at the beginning and go to the end, you're going to loop from what is essentially index number 1 to index number 4. And if you want to call every single one in the list, then you'll increment by 1 so that you don't skip anyone. So you might say, well, what on earth why would it not be 1? Isn't 1 what it will always be? Well, it is the default. Like I said, most commonly it's a 1, but maybe you're splitting the job up. Maybe you're calling the even people on a large list and somebody else is calling the odd people. And in which case you'd write the loop 2 different ways, each of you starting at a different start, but then incrementing by 2. In this case, we're not doing anything fancy like that. There's only 4 people on the list. So we're going to go from n equals 1 to 4, counting by 1s, do this. And this is where I've got this fake function called placeCall. The real key, though, is we're going to call the named person, and we're going to pick the named person out of the table teammates by passing the integer variable, the index variable, which I called n. So the first time this loop runs, it starts out with n equal 1, so it calls teammates 1. And then it repeats and increments to 2 and calls teammate 2. And then it increments to 3 by counting up by 1 more, calls teammates 3, increments to 4, which will be the end, and calls teammates 4, and then the loop exits. So the code inside between do and end will run 4 times. Each time it runs, it's able to use an integer index that is counting up, called n in this case. All right, then I'm going to switch to screen sharing. Okay, so to To do these, if you want to follow along, you'll need the table. The for loop is being used to loop through a table. But let's start with actually just an even simpler loop, which will just count. So looping, like logic, is not built directly into Java code. You'll use snippets, or you'll write the code in snippets, or anywhere you're allowed to write raw code, kind of, you can type in loops and logic. So I'm going to start with a snippet. So I'm going to name the snippet for loop, and I'm going to pop it out so that you can see what I'm typing, hopefully. Okay, so a really basic for loop uses the keyword for, a counter of some type. I use n. It just has to be a valid Lua identifier, so it can't be a reserved keyword. It has to follow the valid Lua identifier rules that we covered earlier in the semester. Okay, so I'm going to say for n equals 1, comma, let's do 10, do. Now, let me add the last one. I'm going to put the in so that I don't forget it. And now I've got an empty loop body that's going to execute 10 times. It doesn't do anything because there's no code in it, so I'm going to print n equals n. So that should print to the console n equals 1, and then n equals 2, and then n equals 3, and so on until we get to 10, and unless I've mistyped something. So I've already got a folder set up in chapter 6 for the for loop, so I'll put it in there, and I'll just say count to 10. And it did run, and what you'll see is there's an empty device because the print statement doesn't do anything on the device, right? The print statement does stuff to the console, and you can see here at the console it did count from 1 to 10. So if you're following along in some way, you should see this repetition at the console. So our code, the body of our code is just one line, and it repeats 10 times because we've wrapped it inside of a for statement. Anything in between the do and the end will be repeated as the loop is set up. So let's, just to play around, let's change it to for, see what happens. I expect you know what will happen, but I want to double check. So here's our output now, n equals 1, 2, 3, 4. Let me switch it to 20, and I'm going to change this to 2. So now we're going to add 2 each time instead of adding 1. So zooming in, you can see we're hitting now all the odd numbers. We started at 1, which is odd, and we continue to move up to the next odd number each time. So it goes from 1 to finally 19. It stops at 19 because the next time it increments the rule, it exceeds 20, and the loop doesn't go past 20, and so it jumps out of the loop. Okay, so I'm going to close that, and I want to set up my teammates table. So I'm adding another snippet. I'm going to move it up above the first snippet. It's an app variable, and it is a table. So basic table structure is we give it a name. I've called it teammates. If you're following along, notice it's all lowercase letters. If you, like I do sometimes, I capitalize the second M. Remember that Lua is case sensitive, so if you do capitalize it, then you'll need to continue to capitalize it. I'm doing it all lowercase in hopes of remembering that it was all lowercase. Anyway, it's a table. Basic table setup requires the curly braces, so an open and close curly brace, and then I can populate it with data in a couple different formats. I can use key value pairs, or I can just input raw data. So I'm going to input my names. I think I'm out of order already, but the order's not really important. It's Jenny, however you spell that. And this is the one I would probably screw up, Hermione. And obviously you can, if you want to, which I often do, I would break it up so that I can see it all more easily. As long as you're only inserting spaces or end lines, new lines, then this will work fine. So you can reformat a table setup like this. Anyway, this this snippet, which for me is object 2, sets up my teammates table and populates it with people. Now I want to change the loop. I want to go from 1 to 4. I'm going by ones. Instead of printing this, let me just start over. I want to print, let's say we just want to print hello to each of our teammates. So it's a print hello dot dot, and then I said 4 and I typed 3. I'm so sorry. That's a 4. From n equals 1 to 4, do this. And I'm going to say hello dot dot concatenate teammates n. So unless there's a typo in there, I think you should expect that we'll get a list of hello statements at the console. There will be 4 of them, and each of our teammates will be greeted separately, unless there's a typo, in which case that won't happen. All right, there we go. Again, if you type them in a different order, you'll get a different order here. These are going in order from the first data element in the table to the second to the third to the fourth. Tables maintain their order. They take that order that you added them in this case. Okay, so a couple things that are nice about Lua. One is, well, you might have noticed that I mistyped the 4 and did it as a 3. I didn't do it on purpose, but it is something that you can certainly mistype or get confused about, or maybe you've read the data in from another source and you don't know how many people are in your list, right? Maybe it's not your team, maybe it's a list that you're getting of customers or suppliers or something else that you're needing to write some code for. You don't know how many people are in the list because it changes each time the program runs. It reads in data from a database, maybe, and then you need to act on that list. So there's a couple ways to handle it. For simple Lua tables, though, there's actually a little bit of a really nice little bit of syntax. You use the pound sign and then the name of the table. So this is the syntax I'm referring to. Pound teammates, or number teammates. In English, we call that the pound as well. What that does is say how many people are in the teammates list, how many people are in the teammates table. So in this case, pound teammates is 4. So it programmatically returns the number of elements in a simple Lua table. And the caveat is this little bit of syntax, or they call it syntactic sugar, only works for simple Lua tables. If the Lua table was entered using key value pairs, the pound syntax doesn't work. You have to use a longer syntax, which we'll get to when it makes sense with an example. And then I said the 1 was optional. So if you're already tired out from typing all of this in this line of code and you can't bear the thought of these 2 or 3 extra characters, you can omit them and it can show up like this. So this loop, although it does look a bit different than the one we just ran, it is equivalent. We'll get the same result at the console. That is the basic for loop. There's 2 more things I want to talk about. Okay, so first, modest tangent. It might have occurred to you that, wait a minute, your example is, I'm in a team, these are the people in the team. You said the task is you need to contact everyone in the team and tell them that this meeting's coming up. So it might have occurred to you that, well, wait a minute, I wouldn't contact myself, right? I mean, if I'm whoever, let's say Harry, if I'm Harry, I'm not going to call myself. I'm going to skip that person. So then this kind of simple loop doesn't quite work because you're not going to call yourself. If you wanted to make this more realistic, we would need to skip ourself. So just real quickly, how might we do that? Let's say we know our name, and just to make it really explicit, I'm going to put it in a variable. So I'm going to say I'm Ron. Hi, nice to meet you. I want to skip Ron as I'm doing this. So you know how to do that. It has nothing to do with the loop. You're going to add some logic inside that chunk that's being repeated. So you're gonna write an if statement. It's going to surround this print. So I'm just going to type in all of my required keywords, which is if, then, and end. And I'm going to keep indenting over to make my code more readable. But I need to think, okay, what am I testing? I want to say if the teammate that I've pulled up in this repetition is not Ron, then I want to go ahead and make the call. So I want to say if this person that I've read in from the table is teammates N, and I want to say if that teammate is not equal to, the operator in Lua is the tilde equals, and then I want to say my name. So I want to say something like, if teammates N is not equal to my name, then go ahead and do the call. If I hit Ron in this case, then I'm not going to call Ron because I'm Ron, and that would be stupid. Let's see if it works. Hey, coding live's always risky, but you can see if you're trying to follow along, whatever name you picked is not now called. So this has nothing to do really with a for loop. It's a step next, which is doing more stuff with your for loop. In this case, skipping one of the tasks that's in the for loop based on additional logic. Okay, one last example. So far, this example was simple because we could write it all out in a snippet. But in Code, I don't have looping set up or if-then logic set up, which would be a precursor to repetition. So let's do something which is going to be a little bit harder in Code. I'm going to load an image. I hope I've got an image in here that's, oh, there it is, 4-leaf clover. Okay. So it's huge. It will bring you a tremendous amount of luck. I'm going to scale it down though. I do that with the shift key so that it keeps the dimensions. I'm also moving it off screen because part of what I'm going to do is randomly locate it. So I need this script object, which is now too big to see. I need this script object because that's what loads the image, and I want to do this repeatedly. So let's pretend we want to put 4 of these on screen, randomly located. So I want to use a loop, and I said the number is 4, so you know the number, which means the for loop's what you want to use, but I don't have any snippets, and I can't type in this script object, so I have to find some way to put my for loop code above it and below it. And we've covered the surround with snippets approach so far. The second approach is the convert to snippet approach. So I'm going to do it that way. I'm going to highlight the 4-leaf clover, and I'm going to pull down the edit menu and choose convert this object to a snippet. And it's going to, Code's going to ask you or prompt you just to double check that you're sure. You are sure because that's the way we're doing it, but I want you to know the consequences. The consequence of doing this is that script object will be removed from the stack and replaced with a snippet with its code. What that means is you're going to lose access to all of these settings. So before you do a convert to snippet, make sure you've set it up exactly how you want it. So that Code writes the most code for you, and then do the conversion. All right, so if you watch, what you'll see is 4-leaf clover goes away. I leave it in the stack, but pull it out of the generated code. You can delete it if you want to. This is the most conservative way I thought to do it, because if you change your mind and realize, oh my gosh, no, I forgot to set something, you can always go back and kind of undo what you did and reconvert it. But in this case, I'm good to go. There's the converted script object. This is now a snippet. There's the actual Lua Corona script that creates the clover. And now I have stuff I can edit. So I can surround this with my for loop. I can say for n equals 1 comma for do. I'm going to indent like I always do to make stuff easier to read. And I'm going to end it to remind myself that I need to end it, but I want the shamrock not to show up at minus 7657 because that's off screen. This would run now and it would draw for four-leaf clovers off screen so that you couldn't see them. And actually any two fixed numbers here, it would draw four of them and stack them on top of each other so that you couldn't see it. So I don't want either of those options. I want to use my math.random skills, and I'm going to say, put this between, say, what do I normally do, like 20 and 300, and, vertically between, let's say, 20 and 460. But this is the convert to snippet approach. I've taken the script object and converted it into editable snippet code, and then I've surrounded it with my loop. I'm going to save this as 4 clovers. We should get, 4 clovers. And if you hit Command R, you'll restart it and get 4 new randomly located clovers. Kind of fun. Okay, that's the convert to snippet approach. All right. So my plan is Thursday to do your first team activity, so you'll get a chance to meet your team, decide, how much you despise them, how you're going to work together, how you're going to figure everything out, and there will be a small activity as well with something you turn in. Yeah, hopefully it'll be fun. Hopefully you'll love your team and you'll click and you'll be excited about starting this journey over the next several weeks. This is what I wanted to get to today, so I am done.